Welcome to the Explainer. So, we're literally witnessing a massive leap in gaming right now. It's all driven by NVIDIA's AI, and it's completely shifting us from just calculating graphics to actually generating them on the fly.
For decades, gamers and devs have been chasing one massive question. How do we finally cross that uncanny valley and get true Hollywood-level cinematic photorealism right on our PCs?
While the huge roadblock here is time. A real-time game has a blistering 16 milliseconds to render a single frame of action. Compare that to a Hollywood VFX shot, which can literally take hours or days to render offline on huge server farms. The time crunch in gaming is just insane. Check out this massive number, 375,000. That's how much raw computing power has increased since NVIDIA invented the programmable shader back in 2001. But crazy enough, even with all that brute force math, it's still not enough to close the cinematic gap using traditional rendering.
So, we can't just calculate our way there anymore. The real game changer? Generative AI and neural rendering. Instead of traditional math drawing every single pixel, we're now using AI to intelligently predict and generate perfect visuals in real time.
Here's our roadmap for today's explainer. 1. Bridging the cinematic gap. 2. The DLSS 5 breakthrough. 3. AI inside the shaders. 4. Building infinite open worlds. 5. AI-powered game characters. And 6. The new era of gaming. Let's get into it.
Section 2. The DLSS 5 breakthrough.
Looking at NVIDIA's timeline, the progression is super aggressive. We had programmable shaders in 2001, CUDA in 2006, that huge jump to ray tracing and DLSS in 2018, and now, hitting 2025, it's path tracing and the revolutionary DLSS 5. Okay, prepare to have your mind blown. With this latest neural tech, AI is literally drawing 23 out of every 24 pixels on your screen. No joke. You aren't rendering a game the old way anymore. And AI is dynamically hallucinating a flawless world for you, all in real time. But wait, unlike offline AI video generators that just spit out unpredictable, weird stuff, DLS5 is completely deterministic. It takes color and motion data and infuses the scene with photoreal lighting that is perfectly anchored to the developer's 3D content. You get incredible AI realism, but with rock-solid frame-to-frame gameplay. This is exactly why devs are so hyped. Todd Howard from Bethesda points out that with DLSS 5, an artist's vision finally isn't held back by traditional limits. Huge upcoming games like Starfield and Resident Evil Requiem are using this right now to push immersion to absolute cinematic levels. Moving on to Section 3, AI inside the shaders. Think of the NVIDIA RTX kit as a highly specialized developer toolbox. It basically lets creators inject AI straight into the foundation of a game's rendering pipeline, right into the programmable shaders, to pull off incredibly fast path-traced graphics. The practical benefits here are massive. Neural texture compression saves up to 7 times the VRAM without losing quality. Neural materials processes complex stuff, like how light hits silk or porcelain, 5 times faster. And the neural radiance cache actually learns multi-bounce writing on the fly. We're talking huge memory savings paired with insane processing speeds.
Section 4. Building infinite open worlds.
So the lighting is gorgeous, but what about the sheer physical density of a massive open world? Traditional methods completely choke on hundreds of millions of triangles. Mega geometry fixes this by compressing geometry into clusters and reusing them, letting devs build ray tracing structures 100 times faster. For a real-world example, look at CD Projekt Red. They're using this exact mega geometry foliage tech to bring fully path-traced forests to The Witcher 4. We're talking millions of uniquely animated leaves and branches that were literally impossible to render in real time before. Section 5. AI-powered game characters. So we've got these lush environments, but what about the characters? NVIDIA AC essentially gives an NPC its own brain. Using on-device AI, characters can now perceive you, plan their next moves, and speak dynamically without needing a constant cloud connection or boring pre-written dialogue trees. The secret sauce here is efficiency. As Zohaib Ahmed from Resemble.ai says, you have to pack these emotional AI models into a super small memory footprint. You definitely want smart characters, but you absolutely don't want them eating up the VRAM needed for those stunning RTS graphics. Section 6. The new era of gaming.
Taking a step back, NVIDIA GeForce RTX AI PCs are fundamentally changing the landscape. Yes, they boost productivity, but for gaming, DLSS 5 gives us cinema-quality visuals, Ace brings autonomous characters to life, and overall, these RTX technologies are completely redefining the limits of what developers can actually build.
Which leaves us with this one final crazy thought to wrap up the explainer. If AI is stepping in to flawlessly fill 23 out of 24 pixels with perfect photorealistic accuracy, how long until we literally cannot tell the difference between a video game and a live-action movie? Thanks for joining me, and I'll catch you next time.